I just want to say welcome to everybody who's new to RCOS and all the new projects that all look really good. And also welcome to my two new group mates. Trevor.
I'm Trevor Zetterson. I'm going to be assisting Jerry with the library development. And this is...
I'm Sean Chase. I'll be developing for the new library and building some of the first programs that actually use it and use it well.
Alright, so for those of you who weren't here last semester, I'm going to try to go through this real quick, but what is Blue Mesh? So, alright, typically you get your new Android phone and you want to play Words with Friends. Alright, so you have kind of two options here of how you're going to do this. You're either going to do it through 3G or through Wi-Fi. Alright, then we connect to a server. Right, so if you're developing kind of, multi-user applications, you're going to need to go through a, stop hitting buttons. You're going to need to go through a server, and you're going to need to write some kind of server-side application and maintain the server, which is not something you really want to be doing. If you're kind of a one person, two people, you don't really have that many resources. And then from the server, you're going to connect to all the other users. And in a game with words, like Words with Friends, kind of like Scrabble, maybe play with 3 people, 4 people. It's not so easy. It doesn't really let you do that. It takes a lot more work, and it's just not. It's a lot of work for a simple game like Words with Friends. Okay, cool. So this is the Blue Mesh approach. Basically, what we're doing is creating a mesh network using Bluetooth, so that we can hop messages between phones and avoid any kind of server-side code and just like servers altogether. We're going to keep it just clients, pretty much, and have like a message passing design for most of our apps. Cool. So how Blue Mesh will work? How it works, though, because it's working.
Well, no, really.
It's almost working. It's getting there. But okay, cool. So basically what we have is the user application who's going to be using our library. And what's going to happen is they create this Blue Mesh service object. And it's really cool because we can keep, at least at this level, this interface, away from any kind of threads. All the calls are non-blocking, so it kind of avoids some stuff there. From there, we create a router object, which basically does all the heavy lifting. It keeps track of messages and people who are connected to the network, all that kind of stuff. And also, the service object creates 2 threads, a client thread and a server thread, which is not client and server in terms of network. It's just in terms of the Bluetooth API. You need a client socket to connect to a server socket. And then you just get kind of generic sockets from there, and you can treat them as neither client or server. And those pass off those generic sockets into the router, and when that happens, the router goes and it creates a read-write thread. And so for every socket that gets passed into the router thread, we get a new rewrite thread that's going to handle connections with the device that's directly connected to whatever we're running. So right now we're still in our first iteration of this semester, and we've gone and, if you remember from last semester, we had a kind of a whole different design. We redesigned it and rebuilt it, and we're testing. So we were up late last night testing. We got to the point where the phones are connecting, passing off the sockets to the rewrite thread. We were sending data and receiving data, except it was kind of clunky. It wasn't really working completely correctly. We really wanted to have a demo for you today, but didn't quite get there. So definitely next presentation we'll have a demo. And what else are we doing? Finalizing our API. So basically what we want to do is, we go to the next slide. Basically export our project as a jar file and let you, download it and link against it in your Android projects, and use it in pretty much everything. Everybody's going to use it. It's going to be amazing. Yeah, but it's a little bit tough to compile an Android project into a jar file. It gets really mad at you. Yeah.
You can actually mark projects in Android now in newer API versions as Android libraries, and then you can just package them like that.
Yeah, so that's what we're doing. I don't know. Is there a way to export it like that? What?
Typically, you just ship your source, and whoever wants to build with it just marks it as a library.
Right. Yeah, I kind of want to avoid like shipping all the source. It's just like a lot to you can kind of get in there and screw it up maybe. So I mean, we did figure out how to export it as a jar, and it worked. And yeah, so that's basically where we're at. So what else there is? Cool. Yeah. So thanks to Sean O'Sullivan, Morthy. Special thanks to Zach for helping us design it, and all the other RCOS members and mentors. You guys are great. Let's see. Questions? Questions?
So it's mesh-based, right? So potentially every host could get packets for everybody else. So is there like some sort of like signature signing or something like that based on the binary version of Blue Mesh that they're running for security reasons? Or do you not envision that being a concern?
Right, so if two...
Like a malicious peer, right?
Okay, yeah. There is, so the way that Bluetooth works is you have like a unique ID for each, I guess, device running, whatever, it's a unique ID for each app using Bluetooth, right? So you're not going to be able to connect to like a Bluetooth app unless you are able to get that ID, which is taken care of, it's supposed to be taken care of at the Bluetooth level, essentially. So like when you make an app, you would have your own unique ID for that app, and then pass it into the Blue Mesh, so that nobody else could kind of.
So I could make like some spoof flying app that. Okay.
Right.
Gotcha.
Yeah, that's the idea at least.
Okay.
Cool.
Are there any range limitations using Bluetooth?
No, it goes on forever. You can. No. Yeah. When we were testing, it worked better when like I wasn't sitting between the phones, and like it's like it's not the greatest, but I mean it's supposed to. It says on it's spec'd out to be like between 10 and 30 feet, but it depends on the hardware and stuff like that. So it's not really meant for.
Not for cross-country words with friends.
Exactly. Yeah, it's kind of smaller. Like groups of friends and maybe even like a classroom, an entire classroom.
That's the last thing you need in your classroom.
Yeah. Well, maybe you could have we could have our slides up, and you could have your phone and be updating slides on everybody's phone at the same time. So classroom use, I don't know, but cool.
Could probably be.
So as far as how it works, so if you have like phone A connected to B and B is connected to C, can A connect to C?
So yeah, essentially A is connected to C through B, and when that's like whenever any of the read-write threads read a message, as of right now, what we're just doing is just sending it out to everybody, so that when any phone connected to it's kind of like a connected graph, and when any node sends out a message, every other node will get it. And as we kind of progress and develop it more, we're gonna have different routing options, hopefully, so that you don't actually have to spam everybody and just ignore the messages that you don't want. Yeah, but that's the basic idea, is that you can send a message to anybody in the network.
Right, and so that's all transparent.
Yeah.
As far as,
Yeah, our API is pretty simple. It's just a constructor, a function you call to launch it, and then
And there's
read and write.
There's write and then pull, and then how it works is you have a queue of messages in the Blue Mesh object. It's a private object, and so pull just takes the most recent thing off or returns and all. There's no messages.
What sort of messages can I send? And can I send messages that might have sensitive data in them?
So what we're just sending is just arrays of bytes. So if you condense, you can pretty much condense anything down into an array of bytes, and it'll just send it off. So yeah, I don't know how like setting objects will work. If I don't know, it gets a little bit more complicated when you try to send more complicated structures through. But as far as from the user level, if you convert whatever you want down into bytes and send it through and convert it back, it should be okay.
I know it's early days still. Do you have like throughput numbers for numbers of hops? You know what I mean?
We-
Like, so if I have to do 10 hops versus 1 hop, how fast can I shoot data through it?
Right. So that's kind of funny. We don't actually have numbers yet, but hopefully within the next couple weeks we will. I don't think the throughput's going to be the big problem. I think the latency connecting devices, because what we're doing right now, we only have one client thread, right? So the server thread kind of sits there and will connect to anything that has the same ID. And the client thread, it kind of iterates through the list of paired devices that you have on your phone. So if you have if you're paired to your car, your headset, all this other stuff, and you go through all those, and it tries to connect, and it times out with maybe 4 or 5 seconds. So we have to figure out a better way to do that. But it does take, once it tries to accept a connection, it takes a few seconds to establish it, and if it fails, it takes 4 seconds. So I think our big problem would be latency, not throughput. But when we had some bug last night where it looked like there was a message bouncing back and forth, and it was going, really fast. So yeah, I don't have actual numbers, but it was going pretty fast. So
It can go quickly.
I think it'll be okay.
So based on your, your implementation, it was client socket, server socket, and then multiple read-write threads. So would they be both interacting with the client and server sockets, or how? I didn't really get how it worked.
Right. So the client and server, those are just threads that run, right? So the server thread has kind of a Bluetooth server socket, so they call it, open, waiting to accept connections, and the client thread is going through all those paired devices and trying to connect to each one of them over and over again. And once that once either the server thread doesn't accept, it completes that, or the client thread connects to a device, it gets this generic socket object. That's what they return. And basically what we're doing is just passing that socket to the router object and letting that spawn off a thread that's just going to handle read and writes that object to that other device. And then the client and server sockets, it goes back and tries to connect to another device. So basically it's just trying to connect to a device, and once it connects, it passes off the socket to a read-write thread to read and write on. Does that make sense?
Yeah. Well, have you tried looking into a polling scenario? Polling instead of having so many threads? I don't know if you've looked into that.
So polling on different.
Yeah, using poll or the other kind of variants where you do it on a single thread, but you just check non-blocking of the sockets. Can I accept anything down, and then just continue on, so that it simplifies the design, and you only need one thread. So is that
Right. The problem with the read-write threads need to be threads because the reads are blocking. So it'll just sit until it reads data.
so you can't do it in a non-blocking style?
That was our goal, is to make it's non-blocking to the user, whoever's the user application. It's a non-blocking. They perceive it as non-blocking, but on our level, yeah, we have to spawn off all these threads. It would be cool to kind of have a timeout or something on the reads, and we could just pull all the reads. But it's something to look into. Maybe if we have some kind of if it starts bogging down apps and stuff, all the threads. But I don't know there's a problem yet. Yeah.
So BlueMesh will try and connect to all devices in the area with Bluetooth, so I'll get a pairing request, or I have to have BlueMesh installed. That's the part I'm not getting.
So what it'll do is it'll try to connect to another Android device running the same Bluetooth application. But it won't try to connect to other stuff. It needs to have that same, when it queries the list, it checks the IDs of whatever app that Bluetooth, so the Bluetooth sockets have this ID associated with them, which basically lets you know what application it's running or what program it's running. So it does a comparison on those before it tries to do anything. Because if those aren't the same, it just kind of ignores it.
So then your current implementation of Bluetooth supports multiple applications on the same phone using BlueMesh at the same time, or is that not done yet?
That, I'm not sure. We haven't exactly tried it. But theoretically it should work. You should be able to, as long as, that's why we kind of made it a library and not a service, so that you can have like you can grab the Bluetooth hardware and open up multiple sockets on that hardware with different IDs.
I would just be interested in seeing what that does to latency on using.
Right. Yeah, I'm sure it's not good. But cool. Any other questions?
Do you use routing protocols or anything to prevent stuff from just completely exploding on the network side?
What do you mean?
Like if every application is running words on whatever the application is, right? You've got 100 people in a room, 100 building, people across the campus, they're all connected. And I send a packet, and it goes to all 100 people, and like for some reason this package and the response is like I want to find a game, or I want to find this person, or whatever. Like, will your network be able to handle that, or do you have something in place that can slow this down?
Right. So right now, no, not at all. But it's definitely something to think about. I don't know that I want to like put limitations on it, just because people might come up with like uses or ways to get around it from the application level. That might be a better solution than me kind of making sure that they're not basically like flooding the network with all these packets and stuff. But I mean, it'd be it's something to think about in the future when we actually test it on big networks. Yeah.
So, will BlueMesh's protocol forward other connections that are the justification that I would have for suggesting it you use it as a service rather than as a library is that way if person A is using BlueMesh application A and person C is using BlueMesh application A and person B in the middle and person A and C are too far away to communicate with each other directly, but person B in the middle is using a different BlueMesh application, then person A and C would still be able to talk to each other in theory.
Right.
I don't know, it's an interesting.
Person B might not appreciate that.
Right.
Well, yeah, that's the other thing. If one person happens to be connecting two large groups without their knowledge, then
right. Yeah. I mean, there's all types of considerations before we explore that. But
that's the difficulty of mesh networks.
Yeah, you can always have something like that going on from the application, just kind of like wrapper and do that. But there's I feel like there's more freedom from the library point of view. Yeah, Josh.
About how long does it take from BlueMesh object creation to packet sending?
It's
let's see.
I don't know if it has
a couple
to
seconds.
All right, you wanna?
process.
Here we go.
well,
All right, ready? There's gonna be like once there's 3 lines of text, it's ready to send packets. As long as it doesn't crash. It could be really embarrassing. But let's see. Oh. Okay, here we go. So pretty
3
fast.
seconds.
Oh, cool.
Yeah.
Pretty fast.
Fantastic.
Yeah.
9 seconds.